Hey Techno Studs! In this video, let's take a deeper dive into binary numbers. In this video, we'll start out by talking about counting in binary numbers. We're going to get into the powers of 2 and see what those look like. And then we're going to wrap things up by just talking about a few binary measurements. In our last video, we talked about binary numbers and took a look at a couple different ways we could look at binary numbers. We talked about the columns, which consisted of 1, 2, 4, and 8, and how if we have 1 in the 8 column, it would be similar to 1 times 8 plus 1 times 4 if there's a 1 in the 4 column, plus 0 times 2 if there's a 0 in the 2's column, plus a 1 times 1 if there's a 1 in the 1's column. So if you add those all up, 8 plus 4 is 12, plus 0 is still 12, plus 1 is 13. So it adds up to 13. We also did briefly mention another way of looking at that as well. So those are some different ways to look at it. We also briefly talked about counting in binary, where we would start out with a 0, and then we count up by 1, so then we add a 1. We count up by another 1, but we can't have a 2 in binary. So that goes to 0, and then we carry a 1 over to the next column. And then we count up by 1 again, so that's 1, 1. And then we add another 1 to it. That becomes a 0, we carry the 1, this column becomes a 0, and we carry another 1, and now we have a 4 involved. And if we see it that we line this up to decimals, this would be a 0, 1, 2, 3, and 4, which adds up. We have a 1 in the 4 column, and that equals 4, so that adds up. We have a 2 in the, a 1 in the 2 column, so that's 2, plus a 1 in the 1 column, so that would equal 3. We've got a 2 in the 2 column, so that equals 2. And 1 in the 1 column equals 1. So everything adds up when it comes to these binary to decimal transitions there. I took the liberty to fill in the whole table here so we can see everything that it looks like when we have 4 digits in binary. So if you take a look at this, you'll, number one, notice that it counts up just like the decimal system, and we would find that that all lines up. But another thing is you can start seeing patterns start occurring with this. For instance, in the 1's column, it goes 0, 1, 0, 1, 0, 1, 0, 1. In the 2's column, we've got 1, 1, 0, 0, 1, 1, 0, 0. In the 4's column, we got 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1. And if you were to guess it, yes, we have 8 ones here in the 8's column. So here's one other table, just as a reference. This is going from decimal to binary. So you can pause the video with this and just take a look at what those numbers look like. Notice that we don't need those first zeros here at the beginning of it. We don't necessarily need those on the front end. Sometimes we include them, sometimes we don't, but we don't need those. So this is just a table that shows us the conversion from decimal to binary. And once again, I would pause some of these, during some of these videos, just pause and just take it in if you need to do that to understand what's happening with these different tables and different slides. One thing that I want to point out with is that it starts at 0 and goes to 15, but that equals 16 different numbers because the 0 counts as the first digit, the first number, the first of this series right here. So since you count 0 in both of these, if you were to count how many numbers there are, it's 0 through 15 in both these cases. But there are 16 different numbers there. Now what's going to happen is the more you work with these numbers, the more you're going to understand them, and the more you're going to pick up patterns on it that's going to make your job a lot easier. That's especially the case with these powers of 2. In fact, this table right here shows you the powers of 2, and I would memorize it because it will come in handy. So what the powers of 2 are is just when you continue to raise 2 to the whatever power. So what I mean by that is 2 to the 0 is 1. 2 to the 1 is 2. To the second power, so that means 2 times 2 equals 4. 2 to the third power, which means 2 times 2 times 2 equals 8. To the fourth power, which is 2 times 2 times 2 times 2 equals 16. Times 2 is 32. Times 2 is 64. I mean, you see the pattern here. 128, 256, 512, 1024. So you're going to want to remember these. These are going to be very critical for you to get down because we're going to use them a lot. In fact, one thing that you'll be doing is where we're going to be counting bits when we are trying to think of, okay, how many networks do we need? Or maybe how many hosts do we need? And if we're thinking about how many networks we need, we're going to be counting up. So we're going to say 1, 2, 4, 6, 8, 16. So make sure that you have this table down. I would pause the video. I would go over it a couple times now. I would write it down. I would study it after this video. I would continue to study it at other times because once again, the powers of 2 are going to be important. Now, it's pretty rare that we just have a bit by itself. Usually they come in groups, and they come in very common groups. So let's talk about a few different names that we call these different groups. First of all, just to clarify, a bit is a 1 or a 0. It's just a single bit, and it is a single digit, and it can either be a 1 or a 0. A nibble is 4 bits. So you put 4 bits next to each other, and now that is a nibble of information. Or, you know, it's also a hexadecimal number. So we'll make translations to hexadecimal numbers. We'll get more into that. But then you also have a byte or an octet. So typically we'll see this known as a byte, but when it comes to things like an IP address, we'll call it an octet. So what a byte is, it's 2 nibbles or 8 bits. And you'll need to know kind of how to translate this, and we're going to use this as we move forward. But most importantly out of all of this is a byte is going to be 8 bits. And one of the reasons why a byte is the most important thing to understand is because it comes up a lot. The byte of information represents a character. So when we were looking at the ASCII characters, notice that there was 8 bits there representing each of the characters. So your keyboard, every single key on your keyboard is going to be represented by a byte of information, 8 bits of information. And same thing with every pixel is measured, is going to be measured how much red by a byte, how much green by a byte, how much blue by a byte. So we see that for every pixel, there's 3 bytes of information just for that one pixel. So we can see this byte come up a lot. A byte is 8 bits. What does that look like? Well, I've got you a table right here. I have a table right here that represents that, right? We've got the 1s column right here. We've got the 2s, the 4s, 8, 16, 32, 64, 128. One of the reasons why the power 2 is going to be so important is because you're going to have to recall this often. It's going to come up often. And on a test, it's going to come up often, depending on what test it is. But if it's a CCNA test, it's going to come up often. So be familiar with those powers of 2. Be familiar with what a byte is. Be familiar with this chart right here. I'm not going to make you count out all 256 numbers on here, but be somewhat familiar with this table right here because we're going to be using it quite a bit. This video is a bit of a pivotal moment in our course. So from here on out, each of the videos is going to start compounding with the information. What I mean by that is if you continue to progress on without fully understanding the concepts that we cover in these videos, it's going to be increasingly difficult to progress and move forward. But if you really get this stuff down video by video, it's going to really serve you well in the long run. So what we covered in here is we talked about counting in binary. It was a little bit of overlap from my last video, but it's an important concept and one that I'm going to actually go over one more time here. Then we talked about the powers of 2 and how important it is to learn the powers of 2. Start studying that. So that's your homework assignment right now, is to study the powers of 2 and get really familiar with that. And then we also talked about binary measurement, some forms of how we measure this data in nibbles and bytes and octets. And you're going to hear those terms used quite often throughout the rest of this course.